time t equal to 0, two particles p and q are set in motion. At time t equal to 0, q has position vector 20I plus 40j meters relative to p. Have a little look at that. 20I plus 40j, out 2 and up 4, say. So here we have our positions, and which one is 20I? Q has position, so Q is up here, P is at the origin here. And we may need an angle in there, we can get that later. P has constant velocity, 3I, so this is P. P has velocity of 3I plus 5j. And Q has constant velocity of, put my P and Q in, 4I minus 3j. And we are asked to find the velocity of Q relative to P. So the velocity of Q relative to P is the velocity of Q minus the velocity of P. So that's going to be equal to 4I minus 3j. Then we're going to have minus the other two, minus 3I minus 5j. So the velocity of Q relative to P, 4I minus 3I, just I, and then minus 3I minus 3j minus 5j, minus 8j. The magnitude of this will be the square root of 1 squared plus 8 squared. Maybe show the examiner what you're doing, which is equal to root 65, which is 8 and a bit, 8 and, it's not going to give me 0.06 meters per second. It is meters per second. And then the direction of this, the inverse tan of 8 over 1 here, 8 over 1, it's going to give me an angle of 82.87 degrees. So where are we going from here? The shortest distance next, and then the time when they're closest together. Okay, let's do a diagram. Okay, let's look at a diagram. Let's see here, we've Q, P down here. We've Q relative to P, I minus 8j, so positive, negative, so coming down in this direction is the velocity of Q relative to P. So what have we got here? We have a position vector of 20I plus 40j, so that the j is 40 and the I is 20. So we can get this angle here. We have this angle from here, which would enable me to get this angle inside the triangle. Just checking the velocity of P, positive, positive, which will be going up in this direction. Velocity of Q is positive, negative, down that direction, and we have the velocity of Q relative to P. So let's get the tan of A, or the inverse tan of the tan of A will be 4 over 2, the inverse tan of 4 over 2. Will give me that angle, 63.43 degrees. And I have 82.87, so add those two together. So that's going to be 145 and 1.3, 146.3. So the other angle is going to be 33.7 degrees inside the triangle. So the shortest distance is going to be along here. So we have the hypotenuse, or well, we can get the hypotenuse. It's going to be the square root of 40 squared plus 20 squared, which works out to be 44.72. Here we're dealing in meters, so that's the hypotenuse. I want this one here opposite, so sine of 33.7 is equal to O, we call it X, over H, 44.72, so X is equal to 44.72 by the sine of 33.7. 44.72 by the sine of 33.7 is 24.8 meters. If it's to the nearest meter, it's 25. So we're asked for the shortest distance. That's part 2. We have it. And then the time when they're closest together, correct to 1 decimal place. Okay, let's get the time. So we need this point along here. Let's call it R. So we need QR. This QR is going to be equal to, well, X was 44.72 sine. So the adjacent one is going to be cos 33.7. And that is going to give 37.21 meters. And we have the relative speed from earlier. We got 8.06 or square root 65. I'll put it in so there's no rounding off. So that's going to be distance divided by relative speed and give me the time interval taken to get there, which is going to be 4.6 seconds. The time when they're closest together is going to be after 4.6 seconds.